Hi, welcome to Wise Guys. Electric field practice question 2. In this video, I'm going to give you a question like this. So, one charge is put on the original, and the other charge Q2 is 20 centimeter away from Q1 on the x direction. These two charges had the same charge, 8 microcoulomb. We're looking for the electric field at the point A, which is 0.2 meter on the y direction from Q1. So looking for electric field, before do that question, we can list the formula we have is first one, the formula is this is a E equals F over Q. This is the definition. The second formula we have E equals K, Q, and R squared. And another formula E equals V over D. So the first one is for definition. The second one, this one, is applied to point charge, only point charge. The third one is plate charge. So obviously this is a point charge. That's why we use this one. So you may say, I also can using the definition, but we need before using this formula, we need to use Coulomb's law, find the force, then using this definition. So two steps. Actually, these two steps we already got this formula. This formula is from Coulomb's law when applied to point charge and the definition. So we have E equal K, Q over R squared. The Q is the source charge, which is, in this question, is Q1 or Q2. The R is the distance from the source charge to the point we're looking for. So first we see we have Q1 and the Q2. So both charge contribute electric field on point A. So that's what we need to do one by one. First, we're looking for E1. E1 is the electric field strength contributed by Q1. So E1 equals K. We're using this formula. K we can apply 9 times 10 to the 9 exponent, multiply Q is 8 microcoulomb, which is 8 times 10 to the negative 6 coulomb. 8 times 10 to the negative 6 coulomb. At the bottom, R squared is the distance from the point we're looking for to the charge. This is 0.2 meter, 0.2 meter squared. Okay? Then we can calculate this one. We got answer is 1.8 times 10 to the 6. The unit of electric field strength is Newton per coulomb. The second we're looking for E2. But by the way, I need to confirm the direction. This is the magnitude. The direction E1 is, see, from Q1 here. The E1 is this way. Because this is positive charge, 8 microcoulomb, and the E1 at point A is the direction of force when you put a positive test charge at point A. So again, say the E1 at the point A is the direction the electric field, the direction of electric field is the direction of electric force when a positive point charge, test charge put there. So because the positive charge is a positive test charge, that's the force goes y direction. That's why also in the electric field direction. And the E2 is the electric field strength at point A and contributed by Q2. So the formula is still using 9 times 10 to the 9 exponent multiplied by Q. Also Q2 is 8 times 10 to the negative 6 coulomb. The distance is here. Right, from Q2 to A, the distance. What about the distance? This distance is because this one is XY is make right triangle. This one is a right triangle, so this one actually is a hypotenuse. So this R, we can find this R. We can using let me say the R is from 2 to A, because we don't need looking for the distance, but we're only looking for the square of this. So the square of this one equals 0.2 square plus another 0.2 square, right? Because the formula is square. So this one gives us 0.08. So we have 0.08 here. So as a result, we find the answer is 9 times 10 to the 5 exponent Newton per coulomb. Okay, what the direction of E2? The direction is if you put a positive test charge here, what is the direction of force? So because positive charge, positive test charge, that's what the direction is for this way, right? So E2. So after you find E1, E2, how to find the EA? The total electric field strength at the point A is the summation of E1 and E2. And because electric field strength is a vector, they not only have magnitude but also have direction. So that's why we cannot just simply add these two numbers. We need the summation is the vector summation, which is E1 vector per E2 vector. So for this situation, we need to use component method. So component method is we need to set up, let's say this is the x direction, this is the y direction, and the E1 and the E2, and after this one, then we find the total E. So we find the E1 is on this direction, which is on x is 0 and the y direction. And E2, we need to separate E2 into x component and y component. And then we add x direction, add y direction, and we find the EA. So we need to go to next page. So we have the same set the table that is more organized. The table we set in this one, so we said this is the x direction, Then we set the y direction. So for E1, because E1 is y direction, which is 1.8 times 10 to the 6 exponent, right? The x direction is 0, only y direction, this is 0. X direction is 1.8 multiplied 10 to the 6 Newton per coulomb, right? The unit is Newton per coulomb. And E2, because E2, we know the direction, we need to find the angle, because this one is 0.2, 0.2. This right triangle is equilateral, is isosceles right triangle, so that's why this is 45 degree. 45 degree, so that's why this is 45. That's why we have angle is, we use this one E2, x direction is using 9 times 10 to the 5 exponent and multiply cosine 45 degree. And the y direction also 9 times 10 to the 5 exponent times sine 45 degree. As we know, cosine 45, sine 45, they have same value, which is 0.707. So we got answer is this one we got is 9 times 10 to the 5 exponent multiply cosine 45, which is 0.707. We got this one is 6.36 times 10 to the 5 exponent. This is also Newton per coulomb. Because the x direction, we know the E2 x direction is go to left, which is negative direction. So we put the negative here. This is positive, goes up, right? And the y direction is goes up. So also positive is 6.36 times 10 to the 5 exponent. Then we can find EA, the resultant, which is x direction, this one still negative 6.36 times 10 to the 5 exponent, unit Newton per coulomb. A y direction, both positive, which is goes up. That's why we add these two together. Add these two numbers, because one is 6 exponent, the other is 5 exponent. That's the result, give us 2.44 times 10 to the 6 exponent. After this one, this is x direction, this is y direction. So you can have this one. Actually, we can draw at this point. This is the x, this is the y. So put here. This is the negative 6 point. This one is EA x. This is EA y. So we got resultant, which is, see, this one is another right triangle. That's why we use Pythagoras theorem to find the resultant is EA equals square root EA x squared per EY AY squared equal this one. You just plug these two numbers. Then we have this one. This is even negative, but after square, still positive, right? and this one is positive 2.44 times 10 to the 6 exponent square. And then we got the answer. Finally, we got the answer EA. We got 2.52 times 10 to the 6 exponent Newton per Coulomb. This is the magnitude. To find the direction, we can find this angle first, because this is the opposite is AY, so the angle theta. We give the angle direction, angle theta. Theta equals inverse tan opposite, which is EAY over adjacent EAX. So theta equals inverse tan. The EAY is this one, is 2.44 times 10 to the 6 over X is 6.36 times 10 to the 5 exponent. When we apply this one, we don't need to put the negative because we already know the angle is this place. Okay, so finally we got the answer. We got is 75.4 degrees. So the angle is this way. (75.4 degrees). If you want to make the angle start from the x0, if you want to express angle at this one, so same thing, or you can use 180, right, minus 75.4 degrees, you got 104.6 degrees. Okay, so this is the magnitude. And this is the direction. Okay. Okay, this one is presented by Weisgart. Thank you.